Okay, here we draw a boost converter with the source, a switch S, an inductor L, a capacitor C, a diode D, and the load R. We have some basic variables: the input voltage Vi, the output voltage Vo, the inductor current IL, the output current IO, the capacitor current IC, the cycle T with the frequency F. On a steady state, we have two phases. When the switch is closed, we have this circle. The current in the inductor increases. The voltage of it equals V in. When the switch is open, we have this circle. The inductor current drops and its voltage equals V in minus V out. In this state, we know the current and the voltage waveforms should become periodic, which means the IL at the beginning of a switching cycle should match that at the end. I name this point as I min and the switching point current value as I max. The current ripple delta I should be I max minus I min. Since Imax can be calculated with the slope of this on-phase line multiplying the time dt, the same way we can get the ripple current on the off-phase. It equals this inverse slope multiplying the time I minus dt. If we remove all the L and T, we got this V out equal V in by 1 minus D. That's our first formula. Notice that in an ideal case, the input power equals to the output power, which means the voltage times current are equal, and the average inductor current plus half ripple is the max value, and minus half ripple is the mean value. To calculate the capacitor C, we know that the C is delta Q by delta V. Let's see how the diode and the capacitor work. When the switch is closed, the diode is reversed biased, so only the capacitor supplies the load. The diode current is 0. The capacitor current is considered to be the same as the output current, but with opposite polarity. The total charge leaves the capacitor during the on state is the surface of this shadow. When the switch is open, the diode is forward biased. The diode current is the same as that of the inductor. The current goes into the capacitor is the difference between the inductor current and the output current. The total charge that goes into the capacitor during the offset state is this shadow. The first shadow is easy to calculate. It's I output times dt. The average diode current is this part on the whole cycle's average. We can calculate the trapezoid surface and then divide it by t. We got 1 minus d times IL. We need to change the IL with the power input. Then we got the I out. Let's do two exercises. For the first exercise, we have D equals 0.5, frequency 20 kilohertz. Minimum current for the inductor is 6A and max is 10A. The input voltage is 15 volts and the resistor is 7.5 ohm. The voltage ripple is 100 millivoltage, and we need to inductor and the capacitor parameter, and we use the voltage ripple formula. Then we get the inductor. For the capacitor, we also have the formula. We only need to get the output average current by using the output voltage divided by resistance. We can use D to retrieve the output voltage from the input voltage. Okay, now the second exercise, we have the input voltage 100 volt and output voltage 300 volt. The inductor 2 millihenz, the frequency 3.33 kilohertz, and the average inductor current is 5 ampere. We need to calculate the minimum and the maximum value of the inductor current. We can calculate the D by using the input-output voltage. Then we need to have the ripple current so that we can get the max and the mean value. The ripple current is the first slope. Then we just need to add or minus half of the ripple current to the average current to get the max and the mean.